IoT security is an end-to-end proposition, and I think Trent, you're going to kick us off on this.
Yeah, real simply, when we look at a security problem, we're always asking ourselves the question of what components store, process, or transmit sensitive data. And sensitive data could be, the user's login name and password. It could be some type of encryption key. It could be actual software or code itself. And we say that if we identify all those components that store, process, or transfer sensitive information, wherever our weakest link is, the weakest link in the chain is where we need to start in terms of how do we improve the security of that system. And when we talk about IoT security, we often think of these four components, right? That all four of these components, hardware, the embedded software, the cloud service that it talks to, and the app or web interface that the end user uses, all four of those components store, process, or transmit sensitive data, and therefore we have to make sure that all four of them are secure to have a secure chain.
Great, thank you for that overview, Trent. So what do you mean by security at the hardware level?
Was that to me?
Yes.
So security at the hardware level is we should be able to authenticate all of the code components that are running on that hardware. We should be able to authenticate any of our communication partners, right? So whether it's a cloud service or maybe I have a Bluetooth device that talks to the device in my home or in my business, I need to be able to authenticate those endpoints so that I know I'm getting authentic data, that if I'm sharing sensitive information with them, that they're authorized to have that, and that I need to have some way to validate that my own code, if I'm the device or the application, that my own code hasn't been tampered with.
All right, great. Thank you, Trent. I might shift this one to Josh. How do you know if your architecture is secure?
Yeah, that's a interesting one. So I would say what I try to do is I try to see that it's secure against the model that I made, right? So you make a threat model, you say, hey, this is the threats that we have. You go to design phase, like a block level diagram, you enumerate the threats, and then you talk with the team and you see that you've tried to mitigate all the threats that you've had. And at security is an iterative process. It's not like a stamped and done thing, but after I would say the team is comfortable that we've thought through all the threats we can. We have mitigations for all those. And at that point, I would say that the team thinks they have a secure architecture for what they're defining, and then we can move forward into development.
All right, and how do you, architecture is one thing, but implementation is another. Is it possible to know if your implementation is secure?
Well, of course, it's not possible to know 100%. I don't even think it's possible to have 100% secure implementation. It's very difficult. But there's certainly stronger and weaker implementations. And of course, we want to be on the strong side. One of the conversations we often have is, I want to make sure that, I don't have a bad day because my company ends up in the front page of the Wall Street Journal for something stupid, right? So some of that, the good news is that there are, there are some formal standards we talked about earlier, but there's also just industry best practices that you want to follow. And you want to make sure that you're doing all those things, because in some ways, best practices are just the kind of the tribal knowledge of the high-tech industry overall, right? That, hey, don't store passwords in clear text on a file on your server. That's a bad idea. And instead, we do know how to store passwords on a server, or particularly we want to store hash passwords on a server. And so, that's an example of a best practice that, that we should be making sure that we follow. Beyond that, of course, having multiple eyes on the way the thing works is always a good idea. We talked earlier about how really every engineer on the development team should be worrying about security. You need to do code reviews. You need to, have conversations during the development process. Depending on the nature of the product and whether it's appropriate for your business case, bringing in an outside person or expert or team do a review before you've launched the product can be a very good idea. So the idea is just to get more eyes on the product and more eyes on the potential vulnerabilities, and make sure that nobody's left a window open to the building we're trying to keep secure.
Thank you, Howdy. Trent, what steps do developers at each level of a product, hardware, software, et cetera, need to consider to ensure that the product is secure?
Yeah, great question. It starts with requirements. Security cannot be an afterthought. We've got to build in those requirements and use cases that are focused on security at the beginning of the design process. Then we need to make sure that during the design and implementation process, whether it's in code or hardware, that we have engineers that have been trained on secure practices. And then at the end of that, we have to have security testing. And only if we have all three of those components are we likely to end up with something that's reasonably secure.
Josh, thoughts on that?
For the sorry, I saw the blockchain question, and I was like getting excited about the blockchain question.
I'm sorry, what steps do developers at each level of a product, such as hardware, software, et cetera, need to consider to ensure that the product is secure?
Yeah, so this is like, I think we're all talking about is like, how do we test and how do you know? So if you aren't testing that the fact that it is secure, then it's kind of like, I think it's secure, right? So the way I would say like big companies do that is they have this concept called red teams. And so a red team is constantly attacking their own product, right? So it's typically an internal product, but in the development phase, you can certainly do it. And then, before the product is shipped, that's like the 100% best time. Before the product is, you basically want to do a pen test before the product ships, but with enough time to fix the problems. And then that is essentially testing to see that the implementation is secure.
Makes sense. Howdy, any other thoughts on how to ensure the product is secure?
You just need to keep focusing on it. This is not a checkbox you're going to tick off and be done with. I wholeheartedly agree with Josh and Trent that you should be testing before you ship, but you should keep testing and periodically come back to that. So now I've got a product that's been in the market for a year and a half, and somebody should be taking a look at that or thinking through, what has changed? Has anything changed? And a lot of these could be, operating system releases change, web interfaces change, requirements change. I needed to go bolt on, hey, that Alexa thing came out and now I wanted to add Alexa support to my device. So I went and, added some extra new thing. Well, I probably changed some part of my security risk profile. I think it's just a constant thing to constantly, maybe not worry about, but certainly keep front of mind.